Okay, everybody, this is Eric Hayden with the Weather Service in Newport Morehead City. I'm joined by Sarah Spiegler. She's going to talk a little bit about climate change and sea level rise at the end of today's presentation. I really appreciate everybody joining us. If you haven't done this before, you can raise your hand or ask a question through the webinar itself. We will take those questions at the end. And we try to make this a little bit more interactive than some of our prior weather basics. So we will be asking you questions throughout the presentation. If you have a mic, again, if you have a mobile device or a microphone, you should have a mic available to you. You can answer those questions verbally. All you do is just raise your hand and I'll call on you. If you have any questions, send them through the webinar and we'll get to those at the end. So this presentation is focused mainly on 5th grade weather standards. We're going to go over that. And then again, Sarah's going to talk at the end about sea level rise and climate change. So what do meteorologists do? A lot of different things. Here in the Weather Service, we're going to talk about how we make a forecast and how it varies. But we have meteorologists that are on television, in the military, do research. So a lot of times you might think of meteorologists as just those folks that are on TV, but a lot of meteorologists are working in research and science so that we can continue to improve the forecast itself. We're going to talk a little bit about our local office. I know we have some folks joining us from all over the country. We have over 100 National Weather Service offices across the country itself, and they're spaced out so that we have a good forecast for the local area, that we live in the area that we're forecasting for, and we'll have a much better idea of what's happening with the forecast itself. As far as we're concerned in Eastern North Carolina, we are located at that red dot. It's Newport, North Carolina. We cover the eastern quarter of the state, so places like Greenville and Jacksonville, the Outer Banks, and also the local sounds and oceans out to 20 nautical miles. Across central North Carolina, you're covered by the Raleigh office. Wilmington covers southeast North Carolina, and the Richmond or Wakefield office covers the northeast part of the state. No matter where you live in the country, your local weather service office is open 24/7. So we have at least 2 people on staff all the time. That means weekends, holidays, overnight, middle of the night. And then we'll increase staffing depending on how the weather is. So during Hurricane Florence, our entire staff was there 3 to 7 days. So again, the staffing will really change depending on the weather. And most local offices have up to about 25 people. One of the best ways you can get information from us, the forecast itself, is our website. If you just remember weather.gov, you can click on anywhere in the country and that will give you your local forecast. If you do weather.gov/Newport, that gives you the forecast for our local area. And you can click on the map itself or enter a city, a zip code, and get a detailed forecast. So for example, is it going to be warm the next couple of days? Yes, this is an older forecast, but you can see things like, is it going to rain? Is it going to snow? What's the wind speed for the next couple of days? In addition to the 7-day forecast, again, that tells you high and low temperature, maybe percentage of rain. We do what's called a marine forecast. If you've ever been on a boat, you've ever been to the beach, we do a forecast for those folks. So how high will the waves get? Will we have an issue with rip currents? What is the swell? Those types of things, if you're on a boat, what's the wind speed and direction are certainly very important. In addition, is it going to storm or is it going to be a sunny day? Raise your hand at home if you've ever flown. I know Miss Sarah and I were just talking about when we get back to normal, we're looking forward to doing some traveling. We do an aviation forecast. So anytime a pilot plans a flight, they look at our forecast for planning purposes. How high are the clouds? Is there going to be any fog? What's the wind speed? And based on the forecast, they have a certain amount of fuel that they put on the plane. If the conditions are going to be worse, they actually have more fuel on board in case they need to go to an alternate airport. And we do these forecasts at least 4 times a day. Our local airports include Greenville, Kinston, Jacksonville, and New Bern. And then we update as needed as that forecast changes. One of the last types of forecasts we do is a fire weather forecast. Here locally, we have a lot of national forest around us. So sometimes we have forest fires. And other times they do what's called a controlled or prescribed burn, where they burn the brush so that we don't have worse issues down the road. And they certainly need to have a good forecast. Is it windy? What's the wind direction? That's going to control where the smoke goes. Is it dry enough to burn? Is it too dry? Are we concerned that we might have a fire issue today? So those are some of the different forecasts. Again, a 7-day is probably what you're used to. what's a high and low temperature, chance of rainfall, but you may not have heard of the aviation, marine, or fire weather forecasts that we do behind the scenes. All right, we want to mix it up a little bit and make this more interactive. So we've got some questions coming up. I'm going to ask the question, and then if you have a microphone, I'm going to look at the attendees. Just raise your hand if you think you know the answer, and I will call on you. All right, so first things first. Our first question is, meteorologists make which type of forecast? Do we make a 7-day forecast, an aviation forecast, a marine and fire weather forecast, or is it all of the above? Let's see if we have anybody out there. All right, so Amy Sullivan, I see you got your hand raised, so I'm going to unmute your mic. All right, Amy, are you with us?
Yes.
All right, which one do you think it is?
We think it's all of the above.
All right, let's see if Amy is right, and she is. Thank you very much, Amy. Great job. Very, very good job. So again, just like Amy did, if you have a microphone, raise your hand and we'll call on you and we will unmute the line. So if you're answering at home and you didn't answer it, but you chose D, all the above, that is correct. Very, very good. Miss Sarah likes weather jokes, so we put a couple weather jokes in here. What is the difference between a horse and the weather? Give you a couple seconds to think of that. And Mr. Mike Lees, one of our forecasters, came up with some of these. One is rained up and the other rains down. So hopefully you like that for just a little bit different. I know we can't see your faces, so we just want to kind of loosen this up a little bit with questions and some jokes. So we talked about who we are as a weather service. This is a virtual tour of our office. When things get back to normal, you can email us and take a tour. Any school group or even an individual can come to our office. You'll see on the far right, the thing on the tower is a Doppler radar. The dome-shaped building is actually where we release weather balloons. We'll talk about that in a second. Some of the instruments we use to make a forecast, we really have to know what's going on with the weather before we make any type of forecast. So we use rain gauges to measure precipitation, a wind vane to determine the direction. The anemometer tells us the wind speed. A thermometer tells us is it warm or cold. A hygrometer tells us how much moisture is in the atmosphere. And a barometer tells us about pressure. We need to know what's happening now on the ground where we live before we can predict the future. If we have a really good idea of what's happening now, that helps us for our forecast down the road. I mentioned all those instruments are at the ground. We also need to know what's happening in the atmosphere above us. And that's where we use a weather balloon. It's usually about my arm's length wide when we fill it up. And at the end, I'm going to show you that we've got some videos on YouTube where you can see this whole process where we did a video in the past. Attached to that weather balloon is a little radio sign. And it's basically a small weather station. It's on the lower right of this picture. It's in styrofoam to protect it. And as it goes up in the atmosphere, it measures everything we need to know: temperature, wind speed, humidity, and pressure. And we do this twice a day at about 3/4 of the office in the country. To show you how significant this is, prior to Florence or a big severe weather outbreak, we actually do this 4 times a day to measure, again, the atmosphere above us. So we started out small, thermometer, anemometer, kind of our backyard weather. Then we talked about the weather balloon measuring the air above us. The Doppler radar can do the same thing. Up to a couple hours around us, it can detect things like rain or snow or hail. Because of the Doppler effect, we can also measure winds blowing toward and away from the radar itself. And while we don't actually see tornadoes, that can show us where there's rotation in the atmosphere. So the radar is very important. On the lower left, you see that guy, the gentleman, he's about 6 feet tall. The radar itself is a huge satellite dish. You can barely see it because it was hard to get perspective with him standing. And what you would see from the outside is what looks like a white soccer ball on the tower itself. And then broadening out a little bit more, weather satellites help us determine what's happening all across the world itself. Where you see white on this map are clouds, probably some showers and storms. Where you don't see white on this map, it's sunny skies. And this is how we can see hurricanes weeks and weeks ahead of time. As soon as they come off the coast of Africa as a disturbance, we can see them even though they're thousands of miles away. Not because of radar, not because of measurements, but because the weather satellites show us where all these systems are across the globe. All right, time to turn it over to you for another question. See what we got here. And again, if you're just joining us, if you have a microphone, just raise your hand and we'll call on you if you think you know the answer to this. So meteorologists use instruments at the surface and in the atmosphere above us to measure the weather. Is that true or false? And if you answered one before, just unraise your hand. That way I won't call on the same people twice. So we'll give you a second. Meteorologists use instruments above us and at the surface to measure the weather. Is that true or false? All right, I see Grace has her hand up. Let's see, I'm gonna unmute your mic. All right, Grace, you might have to do it on your end because it's not letting me unmute you. There you go. All right, Grace, what do you think it is? Do you think it's true or false?
True.
Very, very good. Very good job, Grace. So if you're like Grace and you answered true, that is correct. We use instruments not just at the ground, but also the air above us to measure the atmosphere. Excellent job. So we talked a little bit about the Weather Service and we talked about the different forecasts we do and all the instruments we make. Now we're going to talk about the sun, seasons, and pressure systems. And for you at home, again, this is following the 5th grade curriculum. So prior to 5th grade, this is going to give you a heads up. And even if we've got some middle schoolers or high schools on the line today, that's okay because this will be a review and it's all good fundamental things for weather. Weather really starts with the sun itself, and one of the reasons for that is the sun heats the earth differently depending on where you are. On this graphic, you can see that the sun heats the ground and then the ground itself heats the air above it. And depending on how close you are to the ground, the warmer you are. So this is why when you go up higher in elevation, say on a mountain or even an airplane, you're farther away from the surface itself, and that's why you tend to be cooler. So the earth heats up differently based on elevation, but also depending on if you're over the land or water. The land heats up very, very quickly, especially compared to the water, and it also cools really quickly. So right there, you can see there's a difference depending on elevation. Do you live on a mountain or in a lower elevation? And do you live over land or over water? So the earth does not heat up the same. The other reason why the earth doesn't heat up the same is there's much stronger and higher rays, more vertical rays near the equator. So the closer you are to the equator, it's like a flashlight shining it directly on the equator itself, the middle of the earth. You're seeing the most direct rays. The farther and farther you get away from the equator, that light is not quite as direct and you get less radiation. So typically, we see warmer regions are located by the equator. Those types of areas have a higher sun angle. Then the polar regions are colder because of the lower sun angle. So the earth heats up differently on elevation, if you're over land or water, and depending on where you live toward the equator. Then we'll throw another one in there, the change of seasons. The seasons change as the earth revolves around the sun itself. So, and we're long ago, the first day of spring is known as the vernal equinox, which is the first day of spring. We also have the same thing in the fall called the first day of fall. This is when the earth is not tilted toward or away from the sun. It's from the Latin word equal day and equal night. This usually occurs the first day of spring, usually about the 3rd week of March, and the first day of fall would be about the 3rd week of September. And again, the main difference is the earth is not tilted toward or away from the sun itself, and therefore the very strongest rays are located over the equator. I'm going to try to draw on this a little bit. Let's see here. So when this happens, again, the strongest rays are located on the equator itself. As you get away from the equator, the rays are not quite as strong, but it is equal over the equator itself. Gradually, as we get toward the first day of summer here in the northern hemisphere, the earth is slowly tilting toward the sun. And you notice now that the strongest rays of the sun are not on the equator. They're actually up toward the Tropic of Cancer. And that's usually about the 3rd week of June. This occurs in the northern hemisphere. It's usually our longest day, and you got the highest sun angle at noontime. So the first day of summer is when the earth tilts toward the sun. This is only in the northern hemisphere. Think opposite if you live in the southern hemisphere. When we're summer up where we live, it's actually the winter time in the southern hemisphere. And we'll go over that a little bit more here in a second. Gradually, as you head toward fall, the Earth tilts back toward the sun and it's even. And then eventually in the northern hemisphere, the Earth starts tilting away from the sun. When this happens, notice now the strongest rays are in the southern hemisphere, down toward the Tropic of Capricorn. Since our rays are much a lower angle here in the northern hemisphere, we call this the winter solstice. It's usually about the third week in December, and it is the first day of winter here. And again, when it's the first day of winter where we live in the northern hemisphere, it is the first day of summer in the southern hemisphere. It is always the opposite. So whatever we are, it's the opposite down in the southern hemisphere. We're heading toward the first day of summer. When that happens, it'll be the first day of winter down in the southern hemisphere. As you might imagine, we're probably going to ask you a question on this one. So because of the Earth's tilt at 23.5 degrees, what do we get? Do we get day and night? Do we get gravity? Do we get the seasons, winter, spring, summer, and fall? Or do we get the lunar cycle? So I'll look at who has their hand raised if you're just joining us. And Camden has their hand on. I'm going to try to unmute you. It's giving me trouble. You might have to do it. There you go, Camden. All right, Camden, what do you think it is? Because of the Earth's tilt, what do we get? Do we get day and night, gravity, the seasons, letter C, or the lunar cycle?
C.
Very, very good. And if you answered like Camden, C, you are correct. So because of the Earth's tilt, we get the change of seasons. And remember, it's always opposite. If we're winter, it's summer in the southern hemisphere. So I kind of gave that one away. I forgot we asked this one, Sarah. So you should all get this one. When it's summer in the northern hemisphere, what season is it in the southern hemisphere? Is it summer? Is it the same? Is it winter, the opposite? Is it fall, or is it spring? And I know I gave that one away, so we should get this one. All right, Riley. So we got Riley Bridges. You are unmuted. What do you think, Riley?
Winter.
Very, very good. I'm sorry I gave that one away, but that's very, very good. So it's always opposite season depending on the hemisphere. Very, very good. All right, so we talked about the difference in heating based on elevation, if you're over water, the seasons. It is not the same. So if you got anything out of that, it's that the Earth heats up differently. And because of that, uneven heating, we have a difference in pressure. All the blue H's on this map are where pressure is the highest, and all the red L's on this map are where pressure is the lowest. And things like to move from high to low, and we call that wind. So as the air flows from higher pressure to lower pressure, that's what the wind is. If the difference is really, really strong, we get really, really strong winds. If the difference in pressure is not a lot, it's a nice calm day and there's not a lot of wind. So the sun heats up the Earth differently because of the seasons. If you're near the equator, if you're over water or land, that causes a difference in pressure. And ultimately, that's what helps our weather. So now we're going to talk about some weather symbols on the map, and then we're going to turn it over to some weather safety, and then the water cycle, and then we'll get to Sarah with some sea level rise and climate change. With pressure, high pressure is good weather, and that's because the air actually descends in an area of high pressure. So with high pressure, it's usually clear skies and sunshine. The opposite is low pressure. The air converges and actually is forced to rise. And that's what creates clouds, and if they all get together, showers and even some thunderstorms. So high pressure is good weather. We like to think of it as happy weather. This is the weather that you want when you go on vacation, clear skies, usually light winds, dry weather. And that's because, again, the air is sinking. Any clouds that try to form kind of get squashed down. And it's marked on the map with a blue H. The opposite of high pressure is low pressure, lousy weather. It's marked on the map with a red L. And again, the air rises in an area of low pressure, cloudy skies, maybe windy conditions, wet weather. A very intense hurricane is an area of low pressure. So again, lousy weather, clouds and rain is associated with low pressure. We're going to talk a little bit about warm and cold fronts. A cold front is a blue line on the map with blue triangles, and it points in the direction that it's moving. So in the example on the upper right, you can see it's moving from left to right. because of those triangles are pointed off to the right. Behind the cold front, all this blue area is very, very cold air. So along the front itself, you often get showers and thunderstorms, and then behind it, you turn colder. The opposite of a cold front is a warm front. It's marked on the map with a red line. So again, you can use your colors to kind of help you. It has semicircles that are painted in red, and they also point in the direction it's moving. Very similar to a cold front, you can get some showers and thunderstorms along it, but they don't tend to be as deep because the warm air is very light and kind of just rides up over the cold air at the surface. So showers tend to be really flat and shallow instead of thunderstorm clouds, which tend to be very deep. The important thing to remember about a warm front is it brings warmer air. So behind a cold front, it turns colder. Behind a warm front, it turns warmer. And that's really important as we go forward. This is a weather map across the southeast part of the country. We put Raleigh up across the central part of the state to give you an idea. On this map, you can see temperatures are in the 80s on Monday. There's our cold front. We know it's moving from left to right because those arrows are pointing in that direction. And watch what happens behind the front. Nashville, Memphis, Jackson, Mississippi, temperatures are falling. And then eventually as we get toward the middle of the week, again, the front's moving this way because you can see the arrows, the triangles pointing in that direction. Temperatures only around 70 behind the front, but we're still 85 in Raleigh, and then down across Florida are into the 80s. So a cold front brings colder weather. The other thing it can bring, showers and thunderstorms. We go back to the weather map on Monday. We're sunny here in the Carolinas, but notice some thunderstorms right along the front, maybe a few showers behind it. As we get toward Tuesday, the clouds are increasing in North Carolina. We've got some thunderstorms over toward Asheville and down toward Georgia. And then eventually, as that front approaches, showers and thunderstorms in our area. But notice Memphis and Nashville, Tennessee, they've dried out and they don't have any storms. So cold fronts bring colder weather, and right along them, you can get showers and thunderstorms. All right. This one might be a little tougher than some of the first ones. So another knowledge question. High pressure brings what type of weather? Do we get showers and clouds? It doesn't really change anything. Do we get sea, sunshine, and good weather? Or do we get spring? And same thing if you're just joining us, if you just raise your hand in the webinar and we will call you. All right, we've got Danny has his hand raised. Let's see here. And you might just have to, if I have more trouble this time, you might just have to unmute it on your end, Danny, because it's not letting me. All right, there we go, Danny.
C.
All right, so you think it's C?
Yeah.
I think you're right. Good job, Danny. So if you said C like Danny, you are correct. High pressure brings sunshine and good weather. Very, very good job. Awesome. All right. Another one, the most common type of weather associated with the cold front. Is it showers and thunderstorms followed by warmer weather? Is it sunshine and warm air? Is it showers and thunderstorms, then it turns colder, or no changes? So there's a lot to read there. I'll give you a second. Is it A, B, C, or D? Let's see here. Do we have anybody that thinks they know? I don't see any hands raised. Let's see. Oh, I see Riley's back at it. All right, Riley. All right, Riley, what do you think?
C. Showers and thunderstorms, and they get colder.
Yep. So C. Yep. You had the words right. Very, very good. Very good. Great job, Riley. And if you said the same thing as Riley did, showers and thunderstorms and colder, you got it right. Very, very good. Those are, again, can be some hard concepts to understand. So you all are doing a great job. We're about 25 minutes in. We've got just a couple more slides to go. Then we always save the best for last. Then we'll turn it over to Sarah and she'll talk about sea level rise and climate change. A couple slides on the jet stream. The jet stream is really, really strong winds high up in the atmosphere. It can be over 100 miles per hour and they really control our weather. That's why our weather goes west to east. It's following the pattern of the jet stream. North of the jet stream is colder, south of the jet stream is warmer. And we have different types of jet stream. As you might imagine, a polar jet brings colder air, subtropical jet streams bring warmer air. The jet stream is high up in the atmosphere, but we also have currents in the water itself. These circulations move ocean water all over the world, and it keeps some climates warmer than they otherwise would be. One of them is the Gulf Stream. A lot of us are familiar with that locally because people that like to fish, they only have to go about 25 miles off the coast, and there's warm water even during the winter. Well, that conveyor belt of warm water goes all the way over toward Britain, and even though they're at a much farther north latitude, they're much warmer because of that ocean water. So ocean currents move cold and warm water all over the globe. Since we're talking about water, we're going to transition toward the water cycle. Water is really an amazing molecule. It can exist as a solid, like an ice cube, a liquid, such as a glass of water, or a gas, which would be water vapor. And it can go back and forth amongst those states. So again, a water droplet can freeze into a solid, or it can melt back into a liquid. You might, we had the rain last night in our area. You might have had some puddles in your driveway or on your road, and then they disappear. That's water vapor. So it continues to move back and forth. And because of that, we've got the water cycle. You can really pick up anywhere on this, and it goes all the way through. So for example, we'll say precipitation. We'll start there since we had that last night. Some of that water goes into the ground for our drinking and our plants and our trees. Some of that runs off into streams or creeks. Then eventually, some of that surface water, either oceans or creeks, can evaporate back up into the sky. It can be sucked up by trees and plants and transpire to the sky. And you don't see it, but eventually all that water vapor, sometimes we can feel it because we're so humid here in the Carolinas. If you get enough of it, it'll cool and condense and form clouds. If you get enough clouds, you eventually get precipitation. So hopefully you see from that, it's never ending. It's a continuous cycle. It might stay in the ground for a while, but eventually it goes back up into the atmosphere, either through evaporation or transpiration up into the clouds themselves. So these last couple slides, I'm going to talk about some weather safety. I know it's toward the end, but it's really important. And one of the most important ones is rip currents. Unfortunately, that's a bigger killer of people in our area than thunderstorms or hurricanes or flooding. So if you do any swimming at the beach, I know conditions are different now and we're kind of staying home, but when we get back to normal, which we will eventually, and you go to the beach, if there's a high risk for rip currents, you really shouldn't be in the water. That's number one. Number two, a rip current is a very narrow channel of water. It doesn't pull you under, but it pulls you out. And your natural reaction, especially if you get pulled out and you can't stand anymore, is to try to fight it. Especially if mom and dad are saying, get closer, get closer. If you try to fight the rip current, you're swimming against a very strong stream of water, and it's very hard, and that's where people get into trouble. So what we want you to do is to float and then swim left or right or swim parallel. And the reason for that is once you're out of that channel of water, then it's much easier to swim back in. So if you went right in this case, once you're out of the channel of water, then you can come back in very, very easily because you don't have that water pushing you out. I've got younger kids, and I always say at least have a boogie board with you, even if you aren't using it all the time. As soon as you get swept out and you can't stand, you may panic. You might say, what did Mr. Eric say? If you got that boogie board to at least sit on and think for a second, what did he say? Oh, that's right, swim left or parallel, then I can come back in very, very easily. The thing you don't want to do is swim against it because even Olympic swimmers can't fight a rip current. It's so strong. Another severe weather safety tip outside of the beach, tornado or high winds. We had some thunderstorms last night. You don't want to be upstairs. You want to be downstairs in your lowest level. Most of us don't have a basement here locally, but if you're watching from across the country, if you've got a basement, that's a good place to go to. Inside, away from windows, and that's the best place to be from high winds or tornadoes. Another severe weather safety tip, I did this with my kids last night. We were playing outside, having a lot of fun. Sky was starting to get dark, and we heard that first rumble of thunder. When thunder roars, go indoors. If you can hear thunder, you can be struck by lightning. And sometimes when I do school visits, I get a lot of questions. What if this happens? What if that happens? As soon as you hear thunder, if you get inside, you're going to be safe because that gives you a lot of warning before those storms get here. So when thunder roars, you want to get inside. Once you're inside, you want to be away from windows, and you want to be in the lowest level of your home. One thing we do get around here are hurricanes. You may not know this, but hurricanes happen all over the world, but they're called different things. They're called the cyclone in the Indian Ocean. Down in the south, in the southern hemisphere near Australia, they're actually called willy willies, and out toward Japan, they're called typhoons. So they mean the same thing. They're hurricanes, but we just call them different things depending on where we are in the world. Hurricanes need very, very warm water, 80-degree water or higher to really form. And this is why when they go over land, eventually they die off. They need that warm air to rise, condense, and form more showers and thunderstorms. And notice that L on the map. A hurricane is a form of low pressure, and that's certainly lousy weather. Here's how a hurricane looks. A lot of times we talk about the eye of the hurricane. That's the center. If you went into the eye itself, it's actually sunny and calm winds because the air is rising so strong right in the center itself. However, right around the eye is the most dangerous part of the hurricane. That's the eye wall. That's where we have the strongest winds and heaviest rains. And then as the hurricane is spinning counterclockwise, again, it's an area of low pressure, you have these bands of heavier rain. And in those, you can have some gusty winds, some heavy rain, and even tornadoes. If you live in our area, we saw that with Hurricane Dorian. The first rain band that moved ashore did produce a tornado on Emerald Isle. And that's very common for these outer rain bands to produce tornadoes. One issue we have with hurricanes, a lot of people focus on the winds, but most people that have issues are from floodwaters, either storm surge or flooding. So our campaign with that is turn around, don't drown. It only takes a little bit of water to sweep you off your feet and just a couple of feet of water to sweep your car away. So never, ever, ever cross flooded roads. Most deaths that occur in flooding occur in vehicles. It's not because the water came up all of a sudden. So as we transition to Sarah, you'll get ready in just a second. I got a couple more slides, but she requested some weather jokes. So what's the difference between weather and climate? You can't weather a tree, but you can climb it. So Sarah asked for a couple jokes. We're going to briefly, 2 slides, talk about weather and climate and transition to Sarah. We're about the 32-minute mark, so we're actually doing really well. Weather is short term. It's minutes to days. It's variations in the atmosphere. So how warm is it? What's the humidity now? What's the precipitation? Is it raining? Is it snowing? It's now. What's happening now? Climate is the average of the weather over many years. So just like weather can change in a couple hours, climate takes hundreds and thousands, even millions of years to change. So the weather is now, and climate is the average over a period of time. So Miss Sarah is on with us. So I'm gonna go over to her presentation and share your screen. All right, 1 second. All right, Miss Sarah, you should have control. And Miss Sarah's gonna talk about sea level rise, and she's an expert with marine and education science. So we really appreciate her being on. I see your one screen, but not the presentation screen. I see it now.
See it now?
Yeah, you just have to do play full screen.
Okay. Do you see the whole screen now, Eric?
I don't. We see like the preview window.
Okay. No, it's all right. Is that better?
It's still the preview. It's better now. Yep. Sorry. It's just
That's okay. Well, first of all, my name is Sarah Spiegler, and I want to say a huge thank you to Eric for inviting me to participate today. Eric and I have done a lot of these programs together now, and it's always very exciting when I get to participate because I get to talk to a lot of students like you, and I get to tell you about my job and what I do, which is, I think, really fun. So as Eric was saying, I'm going to talk to you guys about weather and climate. So for my job, I research climate and climate change. So for me, it's really important that you guys understand the difference between weather and climate. So as Eric was saying, weather is something that happens in the short term. So like today, what is the weather today? If I look out my window right now, I see my cat sitting in the window because it's nice and sunny, and they love sunny weather. So weather can be things like, is it raining outside? Is it sunny? Is it cloudy? Now, when we think about climate, we think about weather over a very long term. So over many years, 20 to 50 to 100 years or more. So it's the average weather conditions over a long period of time. So if you look at the screen, you can see a desert. So the climate in a desert is usually very hot and dry. And that's over many, many years. Another way to think about climate and weather is what are you wearing today? That's, if you're wearing your raincoat because it's raining. But if you think about the climate where you live, what are all the clothes that you have in your closet that you need for the climate over the whole year? And as we're going to talk about, understanding the difference between weather and climate is very important. So I also want to talk to you about some of the work I do here in North Carolina. So I work for a program called North Carolina Sea Grant, and my office is in Morehead City. For those of you that live in North Carolina, I am in the eastern part of North Carolina, and I get to do really cool things like go out in the field with other researchers and scientists. And as you can see, I get to help collect field data. So I do things like take measurements of plants or count how many different types of plants we have in our marshes. And I get to go and work at places like the North Carolina aquariums. And next you're going to see a map of where I work. So I work for a program called North Carolina Sea Grant, and within that program is another program called the North Carolina Sentinel Site Cooperative. And so I'm really lucky. I get to work all along the entire coast of North Carolina, all the way from the Outer Banks in the northern part of our state down through Carteret County. That's where I live in Morehead City. And then down south to Wilmington, which is a big city on the coast of North Carolina. And the things I work on in North Carolina, I think about where our coastal areas are going to be flooded or where there's going to be sea level rise. So if you live in North Carolina and you've ever been to the Outer Banks, you know that those are islands, very remote barrier islands. And as you can see, there's lots of water around those barrier islands. And scientists do a lot of research that shows how flooding and sea level rise can affect those barrier islands. And you can see those red areas show areas in North Carolina that are going to be very susceptible to sea level rise. So what is sea level rise? I'm sure some of you already know what this is or have already learned about it in school. But as our climate changes around the world, so as temperatures get warmer, two things happen that are very important to us. One, the glaciers start melting in the North Pole. And second, as water warms up, because the climate is getting warmer, so as the water gets warmer, something called thermal expansion happens. So as water warms up, it takes up more space. So those two things, when glaciers melt and when water warms up and takes up more space, what we see is flooding on our shoreline. So you can see this picture is where I live, right down the street from Morehead City is Beaufort, North Carolina. And you can see as water takes up more space, it gets closer to our houses and to our stores. So a lot of the research that I do is looking at how all those changes are going to affect us. So this is one of my favorite pictures. You can see the road through Beaufort, and you can see how much water there is. And you can see that as we get more water and more flooding from things like sea level rise and hurricanes, that a lot of places are going to be affected. And here's another beautiful picture of the marshes where I work in North Carolina. So we go out on research boats and we get to do really cool research projects out there where we count marsh plants and we see how the water levels are changing. And so I told you guys that a lot of places where we live are going to start being affected by climate change and sea level rise, but guess what? A lot of places where we live are already being affected by flooding. So this is me kayaking down the street in my hometown of Beaufort, North Carolina, And these, it looks really fun, but you can see those restaurants and those stores in the background, they're getting water into their stores, and that's not good. We all know that flooding can cause a lot of problems. So this is something that researchers and scientists and communities are working a lot on. How are we going to, what are we going to do when we get more water and more flooding into our homes and into our businesses? So we have a lot of really smart people working on these challenges that we have in North Carolina and around our country. But there are things that you guys can do too to help your communities and to help your, whether you live at the beach or whether you live in the middle of the state. So something I like to do is go out and help plant marsh plants with our local nonprofits or local community groups. This is actually our state Rachel Carson Reserve planting marsh plants that help protect the shoreline. So there's many things that you guys can do as kids where you can go out and you can help volunteer in your community. So that's all I have today. I'm really excited that you guys all called in and are learning about weather and climate. And I'm always happy to talk more about what I do. My email address is right down there. I'm always really excited to work with the Weather Service. Eric and the guys at the other people that work at the Weather Service are really good at their jobs, and they are really helpful when we have hurricanes. So they're a really great group to work with. And Eric, thank you again for inviting me today.
Yeah, no problem, Sarah. Great job. We're just about done here. I'm going to ask them one more question. I think I've got it now. All right, we got one more question, then we're going to turn it over to you. Think of some questions that you have for Sarah and I. We aim for about 45 minutes, and Sarah, we're right on track at 41, so this is good. Sarah and I had added some more interactive questions based on some feedback we got, so we just want to make sure we're staying on time, and it looks like we're doing well. All right, so last knowledge question. This goes back to the hurricane one. I hear a little bit. Okay. Here we go. So this goes back to the one that we did on hurricanes. What is the fuel source for a hurricane? And just a reminder, just raise your hand if you think you know the answer, and I will call on you. Is it cold air? Is it rotation of the earth? Is it warm ocean water, or is it tornadoes? What is the fuel source for a hurricane? Let's see here. We'll try Camden. I see Camden and Riley are to that, and hopefully those that aren't asking, answering, it might just be a technology issue. Let's see. All right, Camden, you are good to go. What do you think the fuel source is for a hurricane?
C.
C?
Water.
Very, very good. So for those that answered C along with Camden, excellent job. Very, very good. So it is warm ocean water. Outstanding. So we'll go to the last slide is my email. For anybody who has questions, I know Sarah had one up before, just shoot me an email. How this is going to work is after the class itself, you're going to get a certificate and you will hear from me. You have some weather links. I'll probably send it out today, if not tomorrow. We've got one more class coming up at 1 o'clock. So you'll hear from me. Let me just, I hear a little bit of background noise. I don't know if we got somebody unmuted. So you'll get a certificate from me and a course follow-up. Please, if you like this, share this with others. We have a lot of people that have attended these, and it's just because of you all getting the word out. So if this is something you like, share our link. I'll last leave you with our upcoming schedule. We're actually going to change some of this and add more classes. So you just did the weather basics. This afternoon, we have a flood skywarn. Any of our skywarn classes are where we train weather spotters. So in the case of flood or hurricane, we're talking about hurricanes and history in our area. Then we train you to report wind or rainfall measurements to us. And then we have another weather basics class in the middle part of April. We are likely going to extend